This video is going to look at topic 3.2, which is properties of solids. So the objective for this topic is to explain the relationship among the macroscopic properties of a substance, the particulate level structure of the substance, and the interaction between these particles. So the properties in a solid are determined by the strength and type of intermolecular forces. So when we're talking about these properties, we're often talking about things like melting point and boiling point, vapor pressure, conductivity, and so many more. So these are things that we're looking at, not just with properties necessarily of solids, but properties in general. These are the types of things that we're looking at. Okay, our first type of solid is an ionic solid. So an ionic solid is made up of ions, so things that are positively and negatively charged. Because they're positively and negatively charged, they have really, really strong interactions, okay? They're really, really strong bonds, essentially, which means it has a low vapor pressure, they have high melting points and high boiling points. Because of the repulsion of the like charges between the different layers, they're very brittle, okay? So they're not going to bend easily. When they're dissolved in water, they are conductive because that makes the ions mobile, and the ions have to be mobile in order for electricity to be conducted. Our next type of solid is called a covalent network solid. So these have really strong covalent interactions or really strong covalent bonds. And so these are things that we're looking at. They form networks like an ionic solid would, except instead of being attractions between opposite charges, they're covalent bonds. So they're sharing electrons between atoms. Because of that, because they're so strong, they have high melting points and high boiling points. 3D structure is very rigid because those bond angles are fixed. Okay, so it's hard for the different parts of the molecules to move because when we talk about bond angles and we think about VSEPR theory, those angles are going to be fixed because there's not going to be any other way for them to orient themselves. However, in substances like graphite, which is layers of carbon atoms, the adjacent layers can move smoothly because there's not going to be any bonds or any interaction between them. So because they form those smooth layers, they peel off very easily, and that's how graphite in our pencils work. Our next type of solids are molecular solids. So these are solids where they have distinct individual units of covalently bonded molecules. So they're held in solid form by relatively weak intermolecular forces. So we get solid carbon dioxide when it's really, really cold. Okay, so we get solid sulfur at room temperature. However, they're still relatively weak intermolecular forces. Because of this, they have low melting points, which means they have to be relatively cold in order to be solids. They have low boiling points, which means it's easy for them to turn into a gas. And they're non-conductive because there's no opportunity for the electrons to be mobile. Sometimes molecular solids are large molecules or polymers, so where we have multiple repeating units, or large biomolecules. Metallic solids are going to be made up of all metal atoms. They have free valence electrons, which means that they are good conductors of heat and electricity because those electrons are free to move between the atoms. The atoms themselves are also easy to move or free to move and shift around. This makes them malleable and ductile. So malleable meaning that they can be bent and they can be shaped easily without breaking. Ductile means that it can be stretched into wires. So this is why we use metals to make wires. We have a type of alloy called an interstitial alloy where the smaller atoms fit in between the bigger atoms. These are more rigid and less malleable, less ductile because those smaller atoms are locking in the structure a little bit. And then our last type of solid are our biomolecules or polymers. So these are often molecular solids, and these interactions happen between different regions in a molecule. So when molecules get big enough, different regions can form intermolecular attractions, which then changes the shape. And so things can fold in on each other because they have intermolecular attractions between different regions of the molecule. How that shape is formed determines the functionality. So we talk about this a lot with proteins. And so the structure of proteins depends a lot on those reactions between the different regions. And then how they bend, how they, the new shape that they form determines how they're actually going to function. So those are our different types of solids and some of the properties related to the particles that make up